Hello, my name is Oleksii Shatalov, and now I'd like to present the work which describes the way for Russian text generation problem. As you can see from title, for this task we took the GPT-2 model from non-profit company OpenAI. Here you can see the table of contents that I'm going to report you during this speech. The first part will be introduction. The second part will be the presentation of dataset we got. The third part will be about model training. And the fourth part will be form with findings. So the problem we have now in NLP and NLG is that it's more difficult to generate text in Russian than in English because of its higher level of informaalizing. And in addition, Russian language is not a basic of international communications we have now in the world. So that's why many research and many articles are based on English, not in Russian. And this is one of the main problems that we have during this research. The second topic we have is that the task is closely connected with context understanding. It's very important to generate contextually understanding system that can take into account the previous and the future words that generated by this model. It's very important to generate contextually coherent narrow profile text because of we don't have the context inside the phrase. All the previous work will be useless. The third problem we have is that mostly such models generate text not about some specific subject area, but for some different random topics. Our task is to adopt model such ways that it will be able to generate text in one or several similar areas. The last two problems can be resolved with the help of using transformers architecture for the artificial neural networks. It will help us to keep the context with the help of inbuilt functionality. Also, such trained models that are based on the architecture have possibly for post-training or fine-tuning. With the help of this technology, we can resolve the third problem. But to resolve the first topic, we have to train model that understands Russian and can generate such context-connected docs. So the goals that we decided to have are the collect and data processing for dataset forming, the model training with different parameters, and the last one is the combine all the previous data and knowledge that we have into the findings and conclusions. Before the beginning of the second part, we will discuss shortly about OpenAI's GPT series of models that we are going to use. The GPT model is designed to predict the next word in the text, forming when repeating the operation and complete coherent text with meaning, context, logic of presentation, and completeness of thought. It was originally designed to answer user questions. Accordingly to the developer, a non-profit company OpenAI, the products they offer can be used in the future to help in speech recognition, articles and publications editing, keeping control to the storytelling quality. The creation of GPT or its full name General Purpose Technology and later Generative Predictive Transformer models began with the announcement and release of GPT-1 in 2018. At that time, of course, it was a breakthrough in the field of text generation and the use of transfer learning technology, which was new at that time. But nevertheless, due to the fact that it was trained on a small amount of data, its work left much to be desired. With announcement of the first generation of GPT, the foundation was laid for continued research in this area. GPT-2, trained on more than 40 gigabytes of data from 8 million web pages, impressed its own developers so much that the company initially released only beta version, citing the malicious use of their brainchild to generate fake news, spam or more. The release of GPT-2 took place in 2019. Immediately after the release, the work on GPT-3 has begun. The third generation of GPT made a closed API, for the same reason, the possibility of using it to harm. We can also assume that the new model has a sufficiently large amount of data that doesn't allow it to be disseminated in the way we're used to. Among other things, a fairly large amount of money was spent on the creation of GPT-3, on the order to several $1 million. And this is one of the key factors that doesn't allow training and teaching it's inefficiently, even with the knowledge of the mathematical apparatus of the structure of the model. Section number 2, we are going to discuss about dataset. Excuse me. The primary task before training was the search of the number of articles the portal we have. So we decided to split it to the three big groups that can be described by words like technologies, cryptocurrencies, and machine learning. So now you can see the slide with source names and approximate number of publications for topic technologies. Here you can see the same table but for the topic machine learning, and here you can see the same table but for the topic cryptocurrencies. So we have filtered some sources because of filtering parameters. You can see them on this slide. There are data size. The higher size is better for us. Article text length, the same level of difficulty in pumping out content. If the page is dynamic and uses hashed JSON, JavaScript and JavaScript requests that get a JSON to generate an front-end part of the application, it's very difficult in some cases to scrap this data and place into the data storage for further processing. Then it's a ratio between the amount of text and other content in the article. So if we'll have, for example, one picture per 3 sentences, and these 3 sentences will be fully connected with this picture, there is no reason to scrape such text because of this media connected context, because such model GPT-2 that we selected in the previous research doesn't work with media and doesn't connect media with text. So after processing and downloading pages from portals, it was already possible to accurately form the representations by the number of articles in the dataset. Here you can see the final dataset. Our dataset cleaning process will include 6 steps to go to the model training. They are clean from HTML tags. Then it's leaf only takes data without media, so it's without pictures, videos, audios, and other embeddings. Rejects clean from rubbish spaces and other symbols. After getting the text from HTML, sometimes it's full of these rubbish symbols. Author date, other useless info elimination. Sometimes during the publication there are some metadata on the page that will disrupt model to be trained properly. Then it's mark data with special tokens. What exactly tokens we used, we will discuss a bit later. And distribute or group all articles. This topic we will discuss right now. Here you can see some strategies of dataset forming. We have three options: distributed group dataset, use each file for each text of article, or place all text into the one file. Separate articles with the help of special tokens, and separate the titles with special tokens also. During some test model training execution, we decided to use the last option, which shows us the best practices in our mind. Here you can see the sample of marked text. In the beginning of the picture, you can see the start article token and start title token. Then after title, you can see the finish title token, and then on the line before the last line, you can see the end token of the article. Then you can see the beginning of the next article. So you can see that we placed these articles step by step, each about each above the each in the one file, and we completed the chain of these articles in one file. Topic number 3, it's about model training. So because of resources needed to these versions of models and the quality of output, we decided to use a middle version of GPT-2 model with 355 parameters. The quality of these generated texts you can see in the article, or maybe because using of some of these models yourself. After test model training executions, we will also got the statistics of different computational devices performance. The most suitable for us because of speed was TPU. You can see it's on this slide. Also, it was a very great idea to train model on the fully marked dataset and then train model for titles only to combine possibilities of both these models. With such architecture, we can use the output of title generator like input for the article generator. Looping was a problem that has been fully described in the article. Shortly, some part of text began to repeat several times, and model couldn't generate the next part of text. It was because of some generating text parameters, top K and temperature. And top K applies for the top words for their probability of next word can be chosen, and temperature is madness coefficient for this model. The lesser temperature, the classical model we use, and the higher temperature, the more math model we are going to use. And the other topic of looping was overfitting. Also, we took into account that model remember the text size, so we decided to filter data set by text size. You can see it in the third topic. And then, after some tries, we unfroze more layers to perform fine-tuning there. The quality of generated articles increased. For the titles, we trained the model also. Dataset was a plain text file with titles of articles from the previous dataset that are separated with new line symbol. So new line symbol is also the service token that we are going to use in our model for the definition of the borders of different parts of text. Here we didn't have at all looping problem. Partly it was because of experience we had applying the past task. But often the first title of article that a model generated was not full or disconnected inside itself by context. So we always took the second one. Also, we prepared all this to integrate to the whole platform that will generate articles. Here you can see the use case diagram for user-system interaction. We can see that a user can apply 3 functions inside the platform that include some inbuilt possibilities of model block with 2 trained models. Here you can see the user interface version of our application. Other functionalities that you could see in the previous slide in the use case diagram can be called with the help of API. Let's go to the fourth topic, fourth part of our presentation. It's about findings and conclusions. So the model can be used in such fields and areas. User question answering, chatbots, speech recognition, articles, publications editing, keeping control of the storytelling quality, learning foreign languages, automatic language translator, virtual assistant. So we decided to have some conclusions, and they are initial pre-trained model selection has been done, initial computing device selection has been done, data sources for data set have been analyzed, data has been prepared for the model training, 2 models have been trained for article and title for article generation, and both models have been integrated to the web application. Thank you for your attention.